Hi, in this video we are going to see about how to improve coverage and capacity, fundamentals of wireless communication. Improving capacity in cellular system. Cell splitting, sectoring, coverage zone are some of the methods for improving capacity in cellular systems. Cell splitting. Subdividing a congested cell into smaller cells is called cell splitting. Sectoring is the directional antenna to control the interference and frequency using. Distributing the coverage of a cell and extends the cell boundary to hard to reach places is called coverage zone. Cell splitting. This figure shows the cell splitting. A cell is subdivided into microcell, which is shown in this figure. Split congested cell into smaller cells. It preserves frequency reuse plan and reduce transmission power. This block diagram shows the illustration of cell splitting within a 3 km by 3 km square. In this, a macro cell is subdivided into microcells. Transmission power reduction P transmission 1 to P transmission 2. Examining the receiving power at the new and old cell boundary is given by these equations, where PR at old cell boundary is given by PT1 R power minus n, and power received PR at new cell boundary is given by PT2 into R by 2 power minus n. If we take n equal to 4 and set the received power equal to each other, where PT2 equal to PT1 by 16. Cell splitting. The transmit power must be reduced by 12 dB in order to fill in the original coverage area. The problem is, if only part of the cell are splitted, different cell size will exist simultaneously. Handoff issues are arised in this cell splitting, where high speed and low speed traffic can be simultaneously accommodated. Due to this, handoffs issues will occur in cell splitting. Activity. Sectoring. Decrease the co-channel interference and keep cell radius R unchanged is called sectoring. In sectoring, each single omnidirectional antenna is replaced by several directional antennas. The directional antenna radiating power within a specified sector. Usually the sectoring is of 60 degree angle and 120 degree angle. By using 60 degree, a macro cell is divided into 6, and by 120 degree sectoring, a macro cell is divided into 3 portions. Due to this, the interference reduction is achieved. By using cell splitting, sectoring, and by using directional antennas, interference is reduced. Microcell zone concept. Antennas are placed at the outer edges of the cell. Any channel may be assigned to any zone by the base station. Mobile is served by the zone with the strongest signal. This figure shows the microcell zone concept. In microcell zone concept, handoff within a cell requires no channel reassignment, and it switches the channel to a different zone site. It reduces interference. and low power is required for this microcell zone concept. The figure shows a macro cell, and within this macro cell 7 microcells are there. A macro cell is split up into 7 microcell. Assessment. Thank you.